Hi Year 11, this is a video about the discriminant of a quadratic equation. Okay, so we've seen the quadratic formula before, and part of the formula, the b squared minus 4ac, just that section, is called the discriminant, and we often see that given a symbol of a little triangle. Now the discriminant gives us some information about the roots of a quadratic equation, or in other words, the intercepts. I'm going to show you three different examples to highlight what the discriminant can tell us. Now this first one, x squared plus 5x minus 3 equals 0, we're solving it using the quadratic formula, and I'm going to do the discriminant bit in yellow. So I've got 5 squared minus 4 times 1 times negative 3 all over 2a. So I'm essentially solving this quadratic equation, and I would solve it and that would give me my x-intercepts. Okay, so let's see how we go. Underneath our square root sign now, the discriminant, which is the bit in yellow, is equal to 37 and divided by 2. Okay, now 37 can't be simplified, so if I wanted to leave my values as exact, I have two answers here. I've got negative 5 plus the square root of 37 divided by 2. And I've also got x equals negative 5 minus the square root of 37 divided by 2. So the thing to note here is that the discriminant is a positive whole number that can't be simplified, 37. So that's our first example. Now, our second one. I'm going to use the equation x squared minus x plus 4 equals 0. Now, once again, I'm going to solve it using the quadratic equation. Solving it would give me my x-intercepts. So I've got 1 plus or minus. Now the discriminant I'll do in yellow again. So it's b squared. So negative 1 squared minus 4 times 1 times 4 all over 2a, which is 2. And let's simplify that down. So it has 1 plus or minus the square root of, now the discriminant, which is the bit in yellow, is negative 15. So straight away we should be seeing a problem here. We can't take the square root of a negative number, so there is actually no solutions here. So there are no x-intercepts. So that's the second example. So the first one we had the discriminant as 37, the second one we have it as a negative number. Now the third example, x squared minus 2x plus 1. So once again, using the formula, just to show you the point of the discriminant. So I'm going to have b squared minus 4ac, which is 4 minus 4, all over 2. So that gives me 2 plus or minus, well, the square root of the discriminant in this case is 0. All over 2. So that gives me 2 divided by 2, which equals 1. Okay, so here are our three examples. In the first example, we have two solutions. So two x-intercepts. In the second example, we have no solution, so that means the graph does not cut the x-intercept at all. And in the third example, we have one solution, which means that it just touches the x-intercept, the x-axis. You might also see this as written as two equal solutions. So I want you to make the link between the discriminant, which in the first case was a positive number, 37, in the second case a negative number, and in the third case it equaled to 0. Okay, so notice that when there are two real roots, and roots just means the x-intercepts, the discriminant is greater than 0. So down here the discriminant was 37, but it can be anything, any number greater than 0. When there are two equal roots or just one, so one intercept, the discriminant equals 0, and that was this third example here. And when there are no real roots and no intercepts, the discriminant is less than 0, and that was our second example. So when it's a negative number, the graph has no x-intercepts. Alright, so we need to look at some terminology. I've already mentioned the word roots. The roots of a quadratic equation are our x-intercepts. So whatever values we have, they're our x-intercepts. We've talked about the fact that the discriminant, if it's greater than 0, will give us two x-intercepts. So here, x-intercepts here. And that happens when the discriminant, the b squared minus 4ac, is greater than 0. All right, now we can talk a little bit about the type of roots that we have. So if the discriminant is just greater than 0, we have what's called two real, unequal, different roots. Now real just means normal numbers, so not imaginary numbers. Unequal means that they're different. So we have two different numbers here. If the discriminant is a perfect square, the roots are rational. Now what does that mean? So if the discriminant equals a perfect square, well it would be 4, 9, 16, etc. Imagine what that happens when we do the square root of the discriminant. Well, we'd have the square root of 4, which would be 2, the square root of 9, which would be 3, the square root of 16, which would be 4. So the effect of that is that when we have our equation, we might have, let's say, 6 plus or minus the square root of one of these perfect square numbers, and we're going to have answers where the x-intercepts are rational. So that means not surds. So it could be whole numbers or fractions. Think about the alternative, which is where the discriminant is not a perfect square. So you might have something like, well, we had 37. It's a surd. If the discriminant is not a perfect square, then our roots will be irrational. So we're going to have surds as our roots, and sometimes we'll do decimals, but mostly we'll leave them as exact values. Alright, so we looked before at what happens when the discriminant itself equals to 0. Remember, discriminant is b squared minus 4ac. So when that equals to 0, we have the square root of 0, which is just equal to 0. What happens with that? Well, the quadratic equation has one real root, or some people say it has two equal roots. It doesn't matter. What does matter is that it just touches the x-axis. Okay, and you can see the two different drawings here. One is where a is greater than 0. So remember, a is the number in front of the x squared. And this one, a is less than 0. And that determines whether the quadratic equation or the parabola is concave up or concave down. Alright, so finally the third example we looked at was where the discriminant was less than 0. So that meant we ended up with a negative number underneath the square root sign, and we know that we can't find the square root of a negative number. So what that means is that there are no x-intercepts. So the parabola will either lie completely above the axis or completely below the axis, the x-axis. And the way we work out which is we look at the A. So if the A is positive, it's going to be concave up, so the whole parabola will be above the x-axis. If the A is negative, then the parabola will be upside down, it'll be concave down, and the whole thing will be below the x-axis. Now there's one more set of terminology that we need to go over, and it's this one here, positive definite and negative definite. What that means is that for a situation where A is greater than 0 and the discriminant is less than 0, so there's no intercepts, the whole function is definitely positive. Everything, all the y values will be positive. There are no negative y values, so we say it's positive definite. Negative definite happens when the a is less than 0, so we're concave down. We also have a negative value of the discriminant, so we know there's no x-intercepts. So every value of the y, so every value of the function will be negative, and we call it negative definite. Okay, so let's do a question. We're going to find the discriminant and state whether the roots of the quadratic equation are real, imaginary, equal, unequal, etc. Okay, so first step, find the discriminant. B squared minus 4ac. So taking that from our equation, 3 squared minus 4 times 2 times 6, and hopefully we're seeing this as a problem already, we get negative 39. So our discriminant is less than 0. What does that mean? It means that there are no solutions, so there are no real roots of the equation. In other words, the quadratic equation, when we graph it, will have no x-intercepts. So think back to your quadratic equation if you're having trouble. Negative b plus or minus the discriminant, which we've just worked out is negative 39 over 2a. Could you solve that? No, you couldn't. So that means there are no solutions, no x-intercepts. Now the question doesn't ask us this, but if it did, we could tell that this quadratic equation is positive definite because the a, so the number in front of the x squared, is positive, which means that it's concave up. There are no solutions, which means the whole graph sits above the x-axis. All right, a slightly different but quite common question. If x squared minus 2kx plus 1 has real roots, evaluate k. Now real roots, discriminant is greater than or equal to 0. So that means that we might have 1 or 2 solutions. So let's work it out. B squared minus 4ac. Now be careful, your b is negative 2k. So negative 2k all squared minus 4 times 1 times 1, which is 4. So we end up with 4k squared minus 4. Alright, now we need this to be greater than or equal to 0. So 4k squared minus 4 greater than or equal to 0. I'm dividing through by 4, which gives me k squared minus 1 greater than or equal to 0. Factorising difference of two squares, k minus 1, k plus 1 is greater than or equal to 0. Now hopefully you've realised that this is a quadratic inequation. So we need to do a quick graph. We would have negative 1 and 1, and we're looking for the parts of the curve which are above the x-axis, so greater than or equal to 0. So it's these bits here. And we want the values of k. So k has to be less than negative 1, less than or equal to negative 1, or k must be greater than or equal to 1. So the trick with this question is to start off with the fact that the discriminant is greater than or equal to 0 and follow through even though you have to do a quadratic inequation.